Hello, my dear students and friends. Today, in this video, I'm going to explain about aldehydes and ketones from the chapter Aldehydes, Ketones, and Carboxylic Acid from class 12 standard. So, this is a complete revision for aldehydes and ketones. Please watch this video up to the end. And if you like this video, please share this to your friends. And if you are new to the channel, please subscribe it. Okay, without wasting my time, let me start. And let me off my camera. Okay, now this is about aldehydes and ketones. This aldehyde is generally represented by RCHO and ketone is generally represented by RCOR, and these two R can be same or different. Okay, if they are same, then symmetrical ketone we can say. If they are different, then unsymmetrical ketones. Okay, and in the next video I'm going to cover this carboxylic acid. Okay, so first of all, IUPAC names of aldehydes and ketones. Aldehydes are named as alkanals. Al is the suffix of aldehyde and the ketones are named as alkanones. Let me give some example here. This is formaldehyde, HCOH. Formaldehyde is called formaldehyde, and this is called methanol. Methane because we have only one carbon atom over here. And in the second example, this is having two carbon atoms, so this is called ethanol, also called acetaldehyde in common name. And this is benzaldehyde, which is both IUPAC and common name. Okay, in the next example I'm giving some ketones. The first ketone is this one, CH3COCH3. This is called propanone because alkanone. Okay, since we have three carbon atoms here, so it has its word root as prop, so propanone, and its common name is acetone. And this is butanone. No need to add 2 because if CO is here, then this number has to be numbered as 2, 1, 2. So the ketone is present in the second carbon atom only, so this is butanone only. And if CH3CO is attached to benzene, then this is called acetophenone. Okay, another example of aldehyde is CH2CH2, and 3 CHO are attached to these three carbon atoms. Okay, so this is drawn like this also. Okay, CH2 CH2 CHO, this is CHO, and this is CHO, sorry. So when I start numbering from this carbon atom 1, 2, 3, 4, 5, then this CHO, this carbon atom would have been left as side chain, so this will feel bad. This is just like, there are three sons. Usually I give this example to my students. There are three sons, and the father gave bikes to the two of his sons, and to the third one he's giving a cycle. These two gets bikes and this one get cycle. So this cycle, the son getting this cycle will feel bad. Okay, so he will ask me, and your son or not, something like that. Okay, so to give this is equal to saying that the father is not giving equal priority to his sons. So to give equal priority to this 3 CHO group, they are not included in main chain, so this is the chain. So numbering is 1, 2, 3. Okay, so this is named as propane 1, 2, 3. And if this C of CHO is not counted in numbering, then the suffix used for aldehyde is carbaldehyde. So propane 1, 2, 3 tricarbaldehyde. Okay, similar is the case here also. This is CHO, which is attached to cyclohexane. So this C is not counted in numbering, but still this is our principal functional group. So carbaldehyde is to be used instead of al. Remember here, when this CHO is counted as 1, this C is counted as 1, and this is 2, then al, we have used al. Okay, this is al when this C is counted in the numbering, but this C is not counted in numbering. These C's are not counted in numbering, so the suffix of aldehyde in this case is carbaldehyde. So this is to be named as cyclohexane carbaldehyde. Okay, here is another example in which both aldehyde and ketone is present. Between aldehyde and ketone, aldehyde is our principal functional group. This is the big brother actually. Okay, aldehyde is a big brother. So this carbon is numbered as 1, 2, 3, 4, 5. So the ketone is in the third carbon atom. So 3-oxo, this is oxo, 3-oxo pentane al, 3-oxo pentanal, 3-oxo, let me write 3-oxo pentanal. Okay, these are some examples of IUPAC nomenclature of aldehydes and ketones. So let us move to the next topic. Next topic is preparation of aldehydes and ketones. Okay, this is the preparation of aldehydes and ketones. So the first preparation of aldehydes and ketones is from alkenes by ozonolysis, and I am taking two examples here. This is an alkene in which we have different alkyl groups attached here, and if it is reacted with ozone followed by zinc hydrolysis, this carbon-carbon double bond is broken and O is attached here and here to obtain this aldehyde CH3 C double bond O. This is our aldehyde obtained from this alkene by ozonolysis, and another compound is CH3CO double bond CH3. This is acetone. This is acetaldehyde and this is acetone. Means we get both aldehydes and ketones from this alkene by ozonolysis. Now if we take this alkene CH3CH2 CH double bond CH CH3, this is pant 2 in, and if ozonolysis is done into this alkene, then this would be broken, and we will get this aldehyde CH3CH2CHO, and this aldehyde CH3CHO. So propanol and ethanol are formed. Okay, so we can get two aldehydes, we can get one aldehyde and one ketone, and we can get two ketones also depending upon the nature of the alkene, right? Okay, next preparation of aldehydes and ketones is from alcohols by oxidation or dehydrogenation. These two reactions are similar, but the reagents are different. For oxidation we use PCC generally, and for dehydration we use copper in presence of 573. So the alcohol is to be heated with copper at 573 Kelvin. Okay, that is the reason for dehydration. Okay, the first example is I am taking here ethanol, which is the primary alcohol. This is 1 degree alcohol, and if this 1 degree alcohol is reacted with PCC or CrO3, PCC is pyridinium chlorochromate, pyridinium chlorochromate. This is a weak oxidizing agent, and this is the best oxidizing agent to convert alcohol to aldehyde. Okay, so in the chains, the one hydrogen is to be removed from this alpha carbon atom. This carbon atom to which OH is attached is alpha carbon atom, and the hydrogen of OH is to be removed, and there will be a double bond between carbon and oxygen to form this aldehyde. This is ethanol and this is ethanol. Okay, so oxidation is a removal of hydrogen. Okay, that change is being occurred here. And in the second example I am taking a secondary alcohol. This is propane 2-ol, and these hydrogens will be out and to form, and carbon and oxygen will be double bond will be formed to form acetone. So ketone is formed from acetone by oxidation or dehydrohalogenation. Okay, let us move to the third preparation of aldehydes and ketones, which can be from alkynes by hydrolysis. So when this ethyne is taken and is reacted with water in presence of an acid, hydrogen will be added to this carbon atom, oxygen OH will be added to this carbon atom. So we will have an enol. This is CH2 double bond CH OH. Okay, this is OH, and in presence of that particular acid, tautomerization takes place. This hydrogen of OH will go to this carbon atom and the pi bond will shift from here to here. So we will get this aldehyde as the product, ethanol from ethene. And if we take a higher alkyne and acidic hydrolysis is occurred, then we will get ketone. So this is propyne. Hydrolysis, acidic hydrolysis takes place, OH goes to this carbon atom according to Markovnikov's rule. So we will get this enol, and after tautomerization, this hydrogen shifts here and pi bond shifts here to form this acetone. Okay, this is tautomerization. Okay, this is called enol form and this is called ketone form. Okay. Now let us move to the next preparation of aldehydes, which is from benzene. Aldehydes and ketones can be prepared from benzene. So when benzene is reacted with carbon monoxide, this is carbon monoxide in presence of HCl, and anhydrous aluminum chloride, then to benzene CHO will be attached. This is electrophilic substitution reaction, and this reaction is called Gattermann-Koch reaction. This is Gattermann-Koch reaction. Okay, this is electrophilic substitution reaction, and the electrophile in this case is our C double bond O H plus. This is our this is our electrophile. Okay, attacking reagent. Attacking reagent, this reaction is this will be our attacking reagent. Okay, but the electrophile attached to benzene is this CHO. Okay, this is called Gattermann-Koch reaction. And in the second reaction, benzene is reacted with acyl chloride CH3COCl in presence of anhydrous AlCl3 to form acetophenone. This is benzaldehyde and this is acetophenone. This is also an electrophilic substitution reaction, and the electrophile in this case is C double bond O CH3, and the plus will be here into this carbonyl carbon atom. Okay, and then the name of this reaction is Friedel-Crafts acylation. Okay, so from benzene also we can prepare both aldehyde and ketone. Okay, let us move to the next preparation of aldehydes and ketones. This is the fourth one, this is the fifth one, from Grignard reagent. So from Grignard reagent we can prepare both aldehyde and ketone again, and Grignard reagent is nothing but RMGX. RMGX is the Grignard reagent. Okay, so CH3MgCl is a Grignard reagent, and here this CH3 will have a negative charge, partial negative charge, which will be a very strong nucleophile, and this nucleophile attacks this CN, because this is partial positive and hydrogen is partial negative, but this carbon is attached to a more electronegative element, nitrogen, so this carbon will have a partial positive charge, so this nucleophile can attack this CN. So this CH is here, to this CN, to this C, we have this alkyl group of the Grignard reagent, and after hydrolysis this N will be replaced by O. So I am not giving the mechanism here. So the trick is the alkyl group of the Grignard reagent is attached to C of CN, and this N is replaced by oxygen from water. This oxygen comes from water actually. Okay, in the similar way we have an aldehyde here. In the similar way we are taking this same Grignard reagent and reacted with ethanidryl. Instead of this hydrogen, alkyl methyl group is here. So in a similar reaction, this CH3 of Grignard reagent will be attached to this carbon atom here, and this N is replaced by O to form our ketone. This is our acetophenol. Okay. Next reaction is Rosenman reduction. This is particularly for preparation of aldehydes only, not ketone. And in this reaction, we take an acyl halide. This is an acyl halide, and if it is reacted with Lindelar's catalyst, this is Lindelar's catalyst, PD barium sulfate, pelladized barium sulfate with hydrogen. So ICl comes out, and Cl is replaced by hydrogen to form our aldehyde. This reaction is called Rosenman reduction. I am giving an example here. This is propanoyl chloride. Okay, and if this propanoyl chloride is reacted with hydrogen in presence of Lindelar's catalyst, so this Cl is to be removed by or kicked out by hydrogen to form this aldehyde. This is our propanol. Okay, let us move to the next preparation. This is Stephan reduction. This is not so clear, so let me write. This is Stephan reduction. Okay, and in Stephan reduction we take an alkane nitrile. This is our RCN, and this is reacted with CnCl2. This is tin chloride followed by hydrolysis. So when alkane nitrile is reacted with tin chloride followed by hydrolysis, then Cn is just replaced by CHO. This is our Stephan reduction. Okay, Stephan reduction. Okay, I'm giving an example here. Let me give. This is not the actual example. Example is here. This is propane nitrile, and this is reacted with tin chloride followed by hydrolysis to form this our propanol. This is our propanol. CH3, CH2, CHO. Okay, aldehyde can also be prepared by reacting alkane nitrile with dibbl H. Okay, followed by hydrolysis. So this Cn is converted into CHO aldehyde. Okay, dibbl is, let me write the structure of dibbl here. This is H. Okay, dibbl means diisobutyl aluminum hydride. So this is our isobutyl. Okay, isobutyl is, this is our isobutyl, CH3 CH2. This is our isobutyl, and two such isobutyl will be attached to aluminium. This is diisobutyl aluminum, and one hydrogen will be attached here. So this is our diisobutyl aluminum hydride. So from here hydride ion come out to act as nucleophile actually. Okay, so when this alkane nitrile is reacted with dibbl H followed by hydrolysis, we can also obtain aldehyde. Okay, this is not Stephan reduction actually. Stephan reduction is the reaction of alkane nitrile with tin chloride followed by hydrolysis to form aldehyde. This is our Stephan reduction. Okay, the last reaction to prepare aldehyde, not aldehyde actually, the last one is preparation of ketone from dialkyl cadmium. Dialkyl cadmium means R2CD. This is our dialkyl cadmium. From dialkyl cadmium we can prepare ketone. So in the first step, how we can prepare this dialkyl cadmium is by reacting with Grignard reagent with cadmium chloride. And when cadmium chloride is reacted with Grignard reagent, then this chlorine will be replaced by alkyl group. So this is our dialkyl cadmium dialkyl. Okay, dialkyl cadmium. Okay, when this dialkyl cadmium is reacted with acyl chloride, RCOCl. So this is our RCOCl. Let me write the reaction here. RC double bond OCl, and if it is reacted with dialkyl cadmium, R2CD, this chlorine is replaced by alkyl group of the dialkyl cadmium. So let me put a dash over here to differentiate from this alkyl group. So we are going to obtain this R dash C double bond O R. This is the ketone to be obtained. So let me write the product of this reaction. This is our what is this? CH3 CH2 COCl. So let me rough this. Okay. Now this is our CH3 CH2 COCl. CH3 CH2 COCl. When this is reacted with cadmium chloride not cadmium chloride, when this is reacted with CH3 dimethyl cadmium, then the product will be this one. Let me change the color. The product will be CH3 CH2 C double bond. This is the part which is written here, and this methyl group will be attached over here to form this ketone. We can prepare both symmetrical and unsymmetrical ketone from this method. Okay, these are some important preparations of aldehydes and ketones which can be asked in your exam. Okay, so let us move quickly to the next topic, that will be our chemical reactions of aldehydes and ketones. Okay, there are 5 chemical reactions of aldehydes and ketones mentioned in your textbook. The first one is nucleophilic addition reaction. Second one will be oxidation. There will be electrophilic substitution reaction, there will be reduction, and there will be aldol reaction and Cannizzaro reaction, which are reactions involving alpha hydrogen. Okay, so the first chemical reaction, which is nucleophilic addition reaction, this is our carbonyl, which is our aldehyde or ketone. CO has this partial positive charge to this carbon and partial negative charge to this oxygen. So a nucleophile can easily attack to this carbon atom to form this adduct. This is just addition of this nucleophile, and usually this O minus abstracts hydrogen from water to form this product. This is the product, general product actually, not a particular one. So in the examples we will get the products. Okay, we'll name the products also. And the reactivity order of aldehydes and ketones with a nucleophile is aldehydes are more reactive than ketones, because in aldehyde there will be hydrogen, there will be one hydrogen in these 2 lines. Okay, because aldehyde is represented generally by this one, so there is one hydrogen, but in ketones there will be 2 alkyl groups which will provide some static hindrance to this nucleophile. So ketones are less reactive than aldehydes towards the nucleophile. Okay, and another reason is this aldehyde is less less reactive, because this carbonyl carbon atom is having more electron deficiency, because this alkyl group gives electrons to this carbon atom, while this hydrogen does not give electrons to this carbon atom. But in case of ketone, 2 alkyl groups will be attached, so this carbon will not have deficiency of electron as compared to this carbon atom. Okay, so nucleophile would easily attack that carbon atom which has more deficiency of electron. But here, since 2 alkyl groups gives their electrons to this carbon atom due to plus I effect, this carbon atom will be less nucleophilic. This hydrogen, this carbon of aldehyde is more nucleophilic, so the nucleophile would like to attack this aldehyde than to attack this ketone. Okay, so suppose this is the reactivity R1, this is the reactivity R2, so R1 will be more than R2. Okay, now let me give one example here. This is our ethanol. This is C double bond O. Okay, this is our ethanol, and if it is reacted with ICN, CNX is a nucleophile to attack this carbon atom. Hydrogen will be attached to this oxygen. So we will get this CH3 CCNHOH. Okay, O will become OH after taking this hydrogen. So this is our cyanohydrin. This is CN. Okay, this is CN. I think this is clear. This is CN, CH3 CNH and the OH. This is cyanohydrin. Okay, and usually this is asked with this type of reaction in continuation, and the reaction is when this CN is hydrolyzed in presence of an acid or base, then this CN is converted into COOH. So carboxylic acid is formed. Okay. Okay, the name of this compound is 1CN. The carbon of CN will be numbered as 1 because this is our principal functional group. 1, 2, 3. So OH is attached to the second carbon atom. So 2-hydroxypropanitrile. 2-hydroxypropanitrile. Generally, such compounds are called cyanohydrin. Okay, the name of this compound is 2-hydroxypropanoic acid. Okay, so let us move this to the next nucleophilic addition reaction, which is with sodium hydrogen sulfide, NaHSO3. Okay, when an aldehyde or ketone is reacted with sodium hydrogen sulfide, then CH3CH SO3H will be attached to this carbon atom as nucleophile, and the sodium will go to oxygen. So this will be our salt actually. So after proton transfer, this sodium goes to this position and the hydrogen goes here to form this compound. Okay, this is again sodium salt. Okay. In the next example, which is important, aldehyde is reacted with an aldehyde. This is propanol is reacted with an alcohol. This is alcohol CH3OH to form hemiacetal. Let me write the reaction here clearly. Oh wait, let me rough this. Okay, because this is an important reaction, so let me write here. This is our C double bond OH. When this is reacted with methanol or ethanol, this will be our nucleophilic part. This oxygen has lone pair of electron. This attacks this carbonyl carbon atom, and hydrogen will be added to this oxygen to form this as the product. CH3, CH2, O will become OH. This is hydrogen, and here methoxy group is attached. So such compound in which methoxy group is attached to the primary carbon atom of alcohol is called hemiacetal. This is called hemiacetal. Okay, and if it is again reacted with another methanol molecule, then this OH and this hydrogen eliminates from water, and OCH3 will be again attached to this carbon atom to form this as the product. See the CH3 Lani. Here again OCH3 will come. This is hydrogen. So such compound in which two alkoxy groups are attached to the same carbon atom are called acetal. This is acetal. Okay, let me name this compound. This is 1-methoxypropan-1-ol, which is written here, I think. 1-methoxypropan-1-ol, and this is named as 1,1-dimethoxypropan. 1,1-dimethoxypropan. This is acetal. Okay, and here I am giving one more example. Let me write this reaction also, because this has been asked in the exam. Okay, this is our acetone. Acetone is reacted with ethylene glycol. This is ethylene glycol, ethane 1,2-diol. Okay, so let me write acetone like this. This is our acetone, and ethylene glycol is this. This is our ethylene glycol. Okay, and this water is removed like this, and to this carbon atom, this oxygen will be attached, this oxygen will be attached to form this product, CH3C, CH3, like this. O, and here this is CH2, CH2, and they will be bonded like this. So this is the product formed. Okay. Okay, now let us move to the next type of nucleophilic addition reaction, which is very important, with ammonia derivatives. This is ammonia derivatives. Okay, so this is our ethanol, and when this ethanol is reacted with NH2, which is hydrazine, okay, these are derivatives of what ammonia. So I can represent these compounds like this, NH2Z. So this is our NH3. Instead of this hydrogen, one of these three hydrogen Z comes. Okay, and this Z can be this, can be this, can be this, can be this, can be this part, can be this big part. Okay, so these are ammonia derivatives, and the reaction is very simple. This is aldehyde or ketone, and this is reacted with these compounds which are derivatives of ammonia. Water goes out like this, O of the carbonyl carbon atom and two hydrogen of this NH2. Okay, so comes out as water, and there will be a double bond between this carbon atom and this nitrogen. So if there is double bond between nitrogen and carbon, such compound will be named as imines. Okay, and derivative Z is attached to this nitrogen atom. So these are the reactions. So this can be the products can be written using this trick. Okay, so let me write the product of this first reaction. When this ethanol is reacted with hydrazine, then this will be our C, hydrogen will be attached over here, and there will be a double bond between this carbon and this nitrogen like this, and this NH2 will be attached like this. Such compound, which is obtained by reacting an aldehyde or ketone with hydrazine, is called hydrazone. This is our hydrazone, right? So let me write the product of the second reaction here. Double bond H and OH. This product is written here. Okay, this is called oxime. Such compound is called oxime. And when an aldehyde is reacted with primary amine, then the product will be our, let me write here, CH3CH double bond N to this, the alkyl group will be attached, methyl, ethyl, phenyl, So let me represent by R. So such compound will be called Schiff's base. Okay, product of this one. And similar is the product with aniline also. Okay, I am not writing the product of aniline. Next one is semicarbazide. This is called semicarbazide, NH2, NHCO, NH2. Okay, let me write the product here. This is our ethanol, and the oxygen and this hydrogen, two hydrogens will go out to form water, and this nitrogen will be attached to oxygen through double bond like this, and the NHC double bond O, NH2 will be attached. So this is semicarbazone. This is called semicarbazide. Remember, these two hydrogens will go out with water, not these two hydrogens. of this NH2 which is directly attached to carbonyl group. Okay, this 2 hydrogen will go out, and this compound is called 2,4-dinitrophenylhydrazine. This is 1, this is 2, 3, 4. So 2,4-dinitrophenylhydrazine. So let me write the product here. CH3, CH double bond, and NH. To this NH, phenyl will be attached. And let me draw the nitro group here because less space is there. NO2. Okay, this is 2,4-dinitrophenylhydrazone. Okay, this is shortly called as 2,4-DNP. Okay, the NP reacts with aldehydes or ketones. This is a characteristic reaction of aldehyde and ketone. And if if a compound reacts with hydrazine to form hydrazone, then a compound has to be aldehyde or ketone. Similarly, if a compound is reacted with hydroxylamine, NH2OH is called hydroxylamine, and hydroxime is formed, then the compound has to be aldehyde and ketone. So these reactions are characteristic reactions of aldehydes and ketones. Okay. Now let us move to the next reaction. This is oxidation. Next type of reaction is oxidation. This is oxidation of aldehydes and ketones. So aldehydes and ketones can be oxidized to carboxylic acid. Okay, so there are 4 oxidation reactions. Oxidation with KMnO4 or K2Cr2O7, which are strong oxidizing agents. When they are reacted with aldehyde, then they will be oxidized to carboxylic acid straight. This is very simple. And the second one is Tollens test, which can be used to distinguish aldehydes from ketones. Means Tollens test are given by aldehydes only, not by ketones. So Tollens reagent is alkaline solution of silver ammoniacal nitrate. Silver ammoniacal nitrate is written in reaction like this only. AgNH32 whole plus. This is our silver ammoniacal nitrate alkaline solution. And if it is reacted with this aliphatic aldehyde or aromatic aldehyde, then they will be oxidized to carboxylate ion. This is COO minus. Okay, carboxylate ion along with silver. So silver mirror will be formed. So Tollens test is also called silver mirror test. Okay, and with Tollens reagents, ketones do not react to form silver mirror. Okay, so if a compound is reacted with Tollens reagent to form silver mirror, the compound has to be an aldehyde, which can be aliphatic or aromatic. Okay, and the next oxidation reaction is Felling's test, Felling solution, which can be used to distinguish aliphatic aldehydes from aromatic aldehydes. Okay. Felling solution is a mixture of copper sulfate solution, which is called Felling solution A, and alkaline solution of sodium potassium tartrate. This is for Felling solution B. Okay, so let me give. Is it given in the next reaction? Yes, this is given here. So I'm not going to write. When this aldehyde is reacted with this copper 2+, which is from copper sulfate, along with this OH minus ion, this is from Felling solution 2, alkaline solution of potassium sodium tartrate. Okay, so simply we write OH minus ion with copper 2+. This is our Felling solution. Okay, now when this is reacted with aldehyde, aliphatic aldehyde without benzene, so we form this carboxylate ion and red brown PPT of cuprous oxide, Cu2O, and if red brown PPT comes out, then the aldehyde has to be an aliphatic aldehyde. So this test is not given by aromatic aldehyde, no red PPT. Okay, the last and very important oxidation reaction is haloform test or iodoform test simply, which are given by those aldehydes and ketones in which directly CH3 is attached to CO of aldehyde or ketone. Okay, not given by other aldehydes or ketones in which CH3 is not directly attached to CO. Okay, so this is an example. This is our acetone, which is reacted with iodine in presence of sodium hydroxide and heated. This is the reagent for iodoform test. Okay, iodine in presence of sodium hydroxide. So this bond is broken, and this part is oxidized to carboxylate ion, and this part, CH3 part, is converted into CHI3, which is our iodoform. So the color of iodoform is yellow. So if yellow PPT comes out, then that particular compound contains CH3 directly attached to CO. So suppose I am giving this aldehyde in which CH3 is present, but this CH3 is not directly attached to CO. So there will be no iodoform test. There will be no yellow PPT of CHI3. Iodoform test is also given by those alcohols on oxidation of which with halogen iodine. Iodine is an oxidizing agent actually. So on oxidation of this alcohol, we are going to get this aldehyde. So in this aldehyde, CH3 is directly attached to CO. So this aldehyde will give iodoform test. So therefore this alcohol will also give iodoform test. So another alcohol which can give iodoform test is this one. This is our propane 2-ol. This can give iodoform test. This alcohol can give iodoform test. Sorry, this has to be alcohol. Okay, this alcohol can give iodoform test because after oxidation this will give butane 2-on, and butane 2-on can give iodoform test. Okay, let me move to the next reaction, reduction. I think reduction. Okay, reduction. The fourth type of reaction is reduction. So aldehydes and ketones can be reduced to alcohols or alkanes, and these alcohols can be primary or secondary. The first one is reduction to alcohol, and for that we are going to react aldehyde or ketone with these reducing agents: hydrogen in presence of nickel or platinum or palladium, or lithium aluminum hydride along with water, or sodium borohydride along with water. Then aldehyde is reduced to primary alcohol. C carbon is the hydrogen C oxygen is hydrogen. Okay, so this alcohol is formed, and if we take a ketone, then hydrogen will come here, hydrogen will come here, so we get a secondary alcohol. So another example is here. So in this case we are going to get this alcohol, which is called benzyl alcohol, again a primary alcohol. Okay, next type of reduction is reduction to alkane, in which we will have two special reaction: Clemmensen reduction and Wolff-Kishner reduction. In Clemmensen reduction, any aldehyde or ketone is reacted with zinc amalgam ZnHg in presence of an acid HCl. Then this CO is just converted into CH2. Rest of the things will remain same. So here are some examples. Ethanol is reacted with zinc amalgam in presence of an acid. So we are going to get this as the product. Here we are going to get CH3, CH2, CH2, CH3. And in the second type of reduction to alkane is Wolff-Kishner reduction. So in Wolff-Kishner reduction, aldehyde or ketone is reacted with hydrazine NH2NH2 along with a base. Then in here also the same change takes place. CO is reduced to CH2. Here are two examples in which I am taking benzaldehyde and reacted with hydrazine in presence of a base. Then we are going to obtain toluene, methyl benzene, and here this is acetophenone. And if acetophenone is reacted with this reagent, then we are going to get this as the product. Okay, these changes can be then, let me write This is generally R C double bond. This is R, H or R. This is reduced to this alkane, right? So this change can be performed by taking hydrogen iodide in presence of red phosphorus, also HIP. Okay, HIP, hydrogen iodide in presence of red phosphorus. The video is somewhat long, but let me complete it. Please bear with me, because I'm going to complete all aldehydes and ketones in a single video. That's why. Okay, let us move to the last reaction, which is our reactions involving alpha hydrogen. There are two reactions here, aldol reaction and the Kenizaro reaction. In aldol reaction and condensation, there must be at least one alpha hydrogen. Okay, for aldol reaction we need one alpha hydrogen. For aldol condensation we need two alpha hydrogens. So aldehydes and ketones containing alpha hydrogen react with a base to form beta hydroxy aldehyde and ketones. This is called aldol reaction, and these aldehydes and ketones along with the base, that mixture is heated, then alpha beta unsaturated aldehydes or ketones are formed. This is our aldol condensation. Okay, here are some examples. This is our aldehyde having 3 alpha hydrogens. So when this is reacted with sodium hydroxide, then this is alpha beta hydroxy aldehyde is formed. This is an example of aldol reaction. So here is the trick for this reaction, for the first reaction. CH3 CHO, another CH3 CHO, hydrogen from alpha carbon atom shifts to this oxygen, and a pi bond shifts to form this sigma bond between these two carbon atoms. Here is the new bond. This is the single bond, not double bond, and this hydrogen is shifted from here, right? And in the second reaction, this ethanol is reacted with sodium hydroxide, and the reaction mixture is heated. Then alpha beta unsaturated aldehyde is formed. So again, I am giving here the trick. CH3CHO, CO is written like this in this direction, and another molecule of the aldehyde is written like this, facing that alpha hydrogen towards this CO. Okay, so we get this water removed out, and there will be a double bond between this carbon atom and this carbon atom. These two carbon atoms are here. These two are carbon atoms, and there is double bond between these two carbon atoms. Okay, this is aldol condensation reaction. Let us move to more examples of aldol condensation reaction and aldol reaction. Here I am taking acetone, okay, and the sodium hydroxide is reacted with acetone. Let me write the product using the tricks only. Okay, CH3 COH, CH3 will come here, and from another molecule hydrogen will go here, has gone here actually. This is our CH2 C double bond O CH3. This will be the product. This is our CH2. Okay, this will be the product. And in the second case, aldol condensation product, we can just remove hydrogen from this alpha and OH from this beta to write the product, or use the trick I have mentioned earlier. Okay, but I am writing the product here like this. This will be the product. Okay, here I am taking an aldehyde which is propanol, and if it is reacted with sodium hydroxide, the product will be, let me write here, CH3 CH2 CO become OH, hydrogen will be here, and this is, remember, alpha carbon atom. From alpha carbon atom, this hydrogen have come actually, so this will be like this. This will be the product of the first reaction. This one is this. Okay, and for the second reaction, you just remove this hydrogen and OH to form double bond here for this. Okay, I'm not writing that product. And in the last example, I am taking these reactions are all simple aldol reaction or simple aldol condensation, And the last example, the fifth one, is cross aldol condensation or cross aldol reaction. This is cross aldol condensation, okay, because heating process is here. So in such reaction we must take two different aldehydes, two different ketones, or one aldehyde and one ketone can be taken, okay. In such case we are going to obtain four compounds as the product, four alpha beta unsaturated aldehydes, okay. So let me write some products for this reaction, okay. For this one we are going to get four products. The first one will be CH3 CH double bond CH CHO. This will be the first one. Second one will be from this aldehyde, that will be our this alpha beta unsaturated aldehyde, CH double bond. I am just writing this, with the trick I have mentioned earlier. I do not memorize the reactions, okay, just I am using the trick. This will be the two products, and these two products will be simple aldol condensation products, and in cross aldol condensation product this will be reacted with this, and in the last one this will be reacted this with this, like this, okay. So this is the first product, this is the second product, and third product is here. Let me write all the products. Let me write here CH double bond with this part will come, okay, actually like this. This will be the third product, and then the fourth product will be this with this will act as electrophile, and this will act as nucleophile. Actually in aldol reaction, one of the aldehydes or ketones acts as aldehyde nucleophile, and another one as nucleophile, okay. In this case both this is acting as both aldehyde and ketone. Here in this product this is acting as electrophile, this part is acting as electrophile, and this part of 3 carbon atoms is acting as nucleophile. Similarly in the last product this part will act as electrophile, like this, CH3 CH2 CH. This will be our electrophile part, and nucleophilic part will be from this aldehyde, that will be like this, CH CHO. So these four will be formed as the products, okay. Okay, now let us move to the last reaction, which is our Cannizzaro reaction. In Cannizzaro reaction we must take those aldehydes having no alpha hydrogen, which will be reacted with a strong base to form a mixture of carboxylate ion and alcohol. So I am taking here formaldehyde, which is reacted with 50% KOH, okay. This is a strong base, and this formic acid when reacted with this, then we will get a carboxylate ion containing the same number of carbon atoms, okay. Here only one carbon atom is here, so the carboxylate ion will also contain one carbon atom only, and the alcohol will also contain one carbon atom only. This is methanol simply. So in the second example, this is a disproportionation type of reaction, okay. So in the second example I'm taking this benzaldehyde to form these two products. One is benzoate ion, another one is benzyl alcohol, okay. This will be our product. So these two are simple Cannizzaro reaction again, and this one in which we are taking two different aldehydes which can occur this Cannizzaro reaction, this is cross Cannizzaro reaction. So the products will be here. Let me write, I'll not, okay, let me keep this for you guys. Please write the products of this reaction in the comment section, okay. And if you cannot write, then please comment also. I will tell in the comment itself the products formed from this reaction, okay. I have covered all the important reactions, preparations of aldehydes and ketones. So I hope you guys understand about this aldehydes and ketones for your examination. This is just some summary, or you can say this as revision for your exam. Okay, let me complete this video, this bit long video of more than 50 minutes. So if you are new to the channel, please subscribe to the channel, and if you like this video, please share this video to your friends. Okay, bye, thank you.